In this video, we are going to talk about osmotic pressure, which is also a colligative property. Before we can really talk about osmotic pressure, though, we need to understand what the process of osmosis is. Now, diffusion is the process of solute particles moving from a higher concentration to a lower concentration, and this disperses evenly throughout the process. Osmosis looks at the solvent. And if water is our solvent, it is looking at the movement of water molecules across a semi-permeable membrane. Now, a semi-permeable membrane is a barrier where only certain things can pass through it. So if this is my semi-permeable membrane right here, notice that the water molecules are able to pass through it, but these larger solute particles cannot. So only water is able to move through it. Water will move by osmosis from low concentration to high concentration regions. And what this does is it kind of evens out the concentrations of the solution. This is really present in our cells. To stop this process from happening, you need a pressure, and that pressure is the osmotic pressure. So the osmotic pressure is just the amount of pressure required to stop the water from moving through that semi-permeable membrane. We can also have reverse osmosis. And that is where you have a pressure that is greater than the osmotic pressure, and you can apply that to impure water. So the water molecules are forced across the membrane to create a pure water sample. We can look at the osmotic pressure and IV fluids. So here are some pictures of blood cells. If you have a hypotonic blood cell, that means that you have lower concentration than the blood. If it is isotonic, that means it is the same concentration. If it is a hypertonic solution, then it has a higher concentration. So that's where you would see cells either becoming very enlarged or shrinking. We can calculate the osmotic pressure using the following equation. This symbol right here is the symbol for osmotic pressure. It is the Greek symbol pi. It is a capital pi, where M is molarity, R is the gas constant, and T is temperature, and it must be in Kelvin because that's the unit of temperature in our gas constant. So let's look at this example right here. An isotonic intravenous saline solution contains 9 grams of sodium chloride per 1 liter of solution. Calculate the osmotic pressure of the solution at 25 degrees Celsius. The first thing I'm going to have to do is calculate the molarity because my equation requires molarity when I only have grams per liter. So I'm going to take my 9 grams of sodium chloride and I'm going to use the molar mass to change it into moles. And the molar mass of sodium chloride is 58.44 grams. So I can calculate the number of moles I have. And when I plug that into my calculator, I get 0.154 moles of sodium chloride. Now I can calculate the molarity. Since I have 1 liter of solution, I can just divide this by 1 liter. And that is going to give me a 0.154 molar solution. If you recall, sodium chloride is soluble in water and it is going to completely dissociate. It's going to act as a strong electrolyte. So it's going to have 2 particles in solution. So that gives me a total molarity of the particles equal to 0.308. Now I can plug all of my stuff, all of my numbers into the equation. So my osmotic pressure is going to be equal to the molarity, which I just calculated, times the gas constant, which is 0.0821 liters times atmospheres over moles times Kelvin. This is not a constant you need to memorize. It will always be provided for you on your quizzes. And then we need to multiply this by the temperature. So our temperature is 25 degrees Celsius. However, if you recall, it needs to be in Kelvin. So in order to change this into Kelvin, I can simply add 273. So when we plug this into our equation, when we plug this into our calculator, I get a pressure of 7.54 atmospheres. If we look at our units, the molarity is going to cancel, Kelvin will cancel, and I'll be left with units of pressure. This is a really high pressure. So you can see the osmotic pressure for this saline solution is going to have to be very high.